Okay, a very good evening. I'd like to bid to our lecturer for Norhayati and all my members. Today, I would like to, we like to talk about the application of the amplifier. Okay, we are given the task to find the application of the amplifier. Okay, the often objective of the amplifier, this assignment is to determine the real application of the amplifier circuit. Okay, to analyze the operation of the amplifier. Okay, now we go on to the first point of the application that we found. Okay, slide. Okay, the application of amplifier that we found is the servo drive, or we can call the servo motor. Okay, first of all, I would like to introduce my group members: Mohammad Izzuddin, Mohammad Azim, Ahmad Zaimul Azid, and myself, Yugan Raj. Okay, first point, we go to the first presentation. Mohammad Izzuddin.
So, Assalamualaikum and very good evening, everyone. So, today I'm gonna explain about name and type of servo drive. So, on this slide shown, there are two pictures that I've gained from the internet. So, this is the two picture of servo drive that can be found at our local market or industry. So for the first picture, this is servo drive of Estune brand. So this type of servo drive is a AC servo drive. Next, I will explain about what is a servo drive. A servo drive is an electronic amplifier used to power electric servo mechanism. Next, a servo drive monitors the feedback signal from the servo mechanism and continually adjusts for deviation from expected behavior. So, this shown a servo drive block diagram that I've gained from the internet source. So, this is a servo drive block diagram. So it's contain several equipment such as which is frequency, sensitive PD, loop filter, power amplifier, and it shows that the servo drive had several step to run this type of servo drive. Next, this shown of a picture of a structure of servo drive. So in this servo drive, there are several parts that I want to explain for this evening. So firstly, there's a stator. What is a stator? From the position of the rotor, a rotating magnetic field is created to efficiently generate torque. Next, winding. So this is winding. Winding is the current flow in the winding to create a rotating magnetic field. So next, as usual, there are bearing, then shaft. This part transmit the motor output power, and the load is driven through the transfer mechanism such as the coupling. Next is about a rotor. Rotor, a high function rated or other permanent magnet is positioned externally to the shaft. So next, this part is the encoder. Encoder, which is the optical encoder, always watches the number of rotation and the position of the shaft. So this right cable is an encoder cable, and this as usual is a motor cable. Next, I will explain a little bit detail about that previous picture. So from the stator, from the position of the rotor, a rotating magnetic field is created to efficiently generate the torque. So winding current flow in the winding to create a rotating magnetic field. Next, a bearing ball bearing, uh, such as the shown picture from the previous slide. Next, shaft. This part transmit the motor output power. The load is driven through the transfer mechanism, such as the coupling. Next, rotor. A high function rare earth or other permanent magnet is positioned externally to the shaft. The encoder, the optical encoder always watches the number of rotation and the position of the shaft. Next, as usual, there's a two cable, which is encoder cable and motor cable. Next, this picture shown of a servo drive. So how the servo drive being used and how the servo drive being connected. So as it's shown, there's a servo drive which is connected to the amplifier, and the servo motor, which is the main topic of the discussion today. So the servo motor being connected to the amplifier, the vector drive, and it will give the current command cable to the through the processor PCB that being connected. Next, I will explain about how does the servo motor functioning. Okay. Typically, the command signal represent a desired velocity, but can also represent a desired torque or position. A sensor attached to the servo motor reports the motor actual status back to the servo drive. Next, the servo drive then compares the actual motor status with the commanded motor status. It then alters the voltage, frequency or pulse width to the motor so as to correct for any deviation from the commanded status. Next, servo drive receives a command signal from a control system, amplifies the signal and transmit electric current to a servo motor in order to produce motion proportional to the command signal. Next, in a properly configured control system, the servo motor rotates at a velocity that very closely approximates the velocity signal being received by the servo drive from the control system. Several parameters such as stiffness, which is also known as proportional gain, damping, also known as derivative gain, and feedback gain can be adjusted to achieve this desired performance. Hence, the process of adjusting this parameter is called performance tuning. Lastly, although many servo motors require a drive specific to the particular motor, brand or model, many drives are now available that are compatible with a wide variety of motors. So that's all from me. So next, I will pass to my friend Muhammad Azim bin Kamuruddin to explain about detail of the servo drive.
Alright. Assalamualaikum and good day to my friends and my beloved lecturer, Madam Yati. Okay. Today I would like to present about servo motor details and the description of this motor servo application. Okay, actually the servo drive controller is a circuit that used to control the position of a servo motor. It is called as a servo motor driver. Consists of a controller and a power supply unit. The servo drive also control a single servo even in a multiple group of servo motor. Next slide. Okay. Next is the component that include in the servo drive motor. Okay. First is essential component, a microcontroller, and also a power supply unit. And for the miscellaneous component is a potentiometer and connector, also etc. for the wire. Next slide. This is the description of component that essential to the servo drive. Okay, it's been driven by applying the voltage signal to its regular interval. Sensitive to timing variation, the duration of pulse varies from 0 millisecond to 2.2 millisecond, and repetition rate is on 50 Hz to 60 Hz. For a single motor control, usually it will use an 8051 Arduino, like 8089S51 or P89V51RD2. For multiple motor, we must use PIC like PIC18F or Atmega. Okay, for next slide. Next slide is the power supply. Power supply of servo motor driver controller depends on the number of servo motor. Servo motor operates from 4.8 volt to 6 volt, but usually in Malaysia, commonly we use 5 volt. The current draw of the motor is variable and depends on the torque that generates. Okay, this is the example of block diagram of operation servo motor. It contains power supply, servo motor, and the microcontroller. Okay, next. Okay, the servo motor has 3 terminals. First terminal is position signal. Sorry. The duration of pulse varies from about 0.5 millisecond for 0 degree, and the rotation 2.2 to 2.2 millisecond for 180 degrees rotation. The pulse need to be given at frequency of about 50 Hz to 60 Hz. Okay. Next is the VCC from the power supply. The servo drive angular position is controlled by applying PWM pulse or in a specific way. Okay, and lastly the ground. So next slide, I will show you the construction of the circuit, how they connect the servo motor to Arduino and the switch. Okay. This is the simple application that relate to our application, which is the Arduino contain the transistor inside the circuitry. Okay, next slide. Okay, for the hardware, it's required 1 Tower Pro SG19 servo motor, 1 Arduino, 3 jumper wire, wiring diagram, servo rack wire for 5 volt pin Arduino, and servo brown wire for ground, and yellow wire for the supply. Next slide. Okay, this is the operation of the circuit. Okay, when the program is start running, the servo motor will rotate slowly from 0 degree to 180 degree, 1 degree at one time. When the motor has rotated into 180 degrees, it will begin to rotate in other direction until it returns to its home position. Okay, I think that's all from me. I will pass my presentation to Muhammad Azim.
Okay, my name is Muhammad Azim bin Kamaruddin, and I want to present about market price of the servo drive. The first one is CNC Shine closed loop hybrid driver plus servo motor. and the second is JSS 57B2N integrated digital hybrid servo shaft, and last is NEMA 33 closed loop stepper motor. Right? Okay, the first one NC left-hand closed loop hybrid driver plus turbo motor. Okay, the seller platform is Shopee. The price is RM 300 ringgit. The voltage is DC input to 70 volt. The breakdown is 256 subdivision, and the current is 4 amp. The top is 2.2 meter, and the rate speed is 1000 RPM, and the maximum speed is 2000 RPM. Okay, next slide. Okay, next is JSS 57B2N integrated digital hybrid turbo shaft. The seller platform is Lazada, and the price is RM 237 and 51 cents, and the voltage is D to 48. It has 0.2 meter integrated digital hybrid turbo shaft, 200 kilohertz closed loop stepper motor, and motor drive integrated hybrid turbo drive system. Okay, next. Okay, last is NEMA 23 closed loop stepper motor kit, and the seller platform of this product is Lazada. The price is 323 ringgit and 59 cents, and the voltage is VDC 20 volt to 50 volt. Maximum current is 6 amp. Fast speed at 2.5 microsecond. Fast pump, fast plus direction, or fast plus pulse. The fast response frequency is maximum 200 kilohertz. Okay, thank
Okay, next one, I'm going to explain about the application of the server drive. Okay, so our we have to we are assigned to talk about four types of the application of server drive. So first one is the server drive in conveyors. Second one is the server drive in camera autofocus. Third one is the server drive in robotic vehicles. And the last one is the server motor in solar tracking system. Okay, we go to the first one. The first application is the server drive in conveyors. Okay, you can see before we go on further, we like to see the video of the conveyors. Okay, you can see the video. From the video, the bottle is moving from one place to another place, so it will be stopped in the middle, and the liquid will be filled, and then it go to the other stage. So this is the server drive is playing the role at the tire part, and from the tire the belt is moving the bottle to the another stage. Okay, go on further. Okay, the conveyors are used in the industrial manufacturing and assembly. Okay, for example, the bottle filling process that's shown in the video. The process of the bottle fill need to clean the liquid and will be moved to the another stage. Okay, the conveyors belt are used with server drive so that the bottle moves precisely to the desired location, and the bottle will be stopped to the liquid will be poured into the bottle, and it will guide it to the next stage. Okay, this is the the server drive is playing the role as the tire. Okay, next we go to the next application. It's at the server drive in the camera auto focus. Okay, you can see from the picture there is the green line. That line is the focus area. You can see the when we take a picture from the camera, we can when we touch the picture will be focusing at the middle, right? So it like that. Okay, we go to explanation. Okay, nowadays the digital camera are very advanced with the features and its abilities for the auto focus and on the object when we capture. So the image of the object is created within the digital signal processor of the camera. So it will be tracked at the sharpness of the picture. Okay, so this server drive is fitted in the camera so that the picture will be more clear and very sharp when we capture the picture. So when you see those days, the picture will be blur, right? So now we were using a server drive in the camera so that picture will be very sharp and clear. Okay, next we go to the next application. It's the server drive in the robotic vehicles. You can see the video. Okay, from the video we can see the vehicle is moving and then stop at the one place and then moving back. I mean, continue. So it will be continue, stop, and continue. So we go to the explanation part. So the roboting nowadays, which are used for highly complex military as well as industrial application, use server drive for the wheels. So this is also using the server drive at the wheels to move, control the vehicles, and stop the vehicle at the one place, and then continue back the vehicle to another place. Okay, the ability of the server is generate enough the torque so as to quickly move the vehicle from halt and then to quickly stop. So it will be moving at one place to another place and then stop and then continue move to another place. So the velocity which the vehicle should move can be controlled by the servo drive. Okay, the last application is a servo motor in solar tracking system. Okay, you can see the in the picture at the left picture, the motor is at the below, and you can have the east sensor and the west sensor, and the sun is on top. Okay, this solar tracking system is used for sun mainly. So you can see the right picture. The small solar panel power is in the middle. I mean, it's in the below, and the main solar panel is on top. It should be facing directly to the sun. Okay. Next. Okay. Okay. You can see the earlier the solar panels that were installed was static and remained at one position of the entire duration of the day. Okay, like you can see the last time we will use the solar panel, it will be facing one place all the time at one day. But when we use the server drive, we when we attach the server drive in the solar panel, it will following the sun. Wherever the sun goes, the solar the solar panel will follow the sun. So we can get the energy, the solar power all the time. So this for earlier time this implies that we are not fully utilizing the power of the sunlight to attract the maximum of the energy out of it. So nowadays, when we attach the server drive to the solar panel in such way that we are able to precisely control its angle of movement at all the time and closely follow the sunlight so we can get more solar power. Okay. So that's all for us for today for the application of the amplifier. Okay, thank you.
So I think that's all from us for this assignment for this semester. So we would like to thank to Madam Norhayati for teaching us for this semester through all the way this sem. Thank you, Madam.